All right. So you can also see that in this particular cluster, there's something interesting going on. It's linkerd sidecar injection skipped because neither the namespace nor the pod have the annotation mentioned here. And what does this mean? It means that in this particular cluster I'm using, there is an add-on called linkerd, and it injects behavior if a namespace or a pod have this particular annotation. So if we look up linkerd, you can see that linkerd is a service mesh. Service meshes will possibly be covered in a future tutorial as a add-on for the Kubernetes tutorial. So it's beyond the scope of this tutorial, but what I can say is service meshes are very handy, and they will provide you with additional behavior in a Kubernetes cluster. And it is an example on how a resource can be annotated to get additional behavior. So what the sidecar pattern does is it uses the annotation. There's also a controller. Their controller will then know, all right, there is a resource, and the resource should have an additional container in the pod. It will then create the container, and this container will be injected into your pods. So although you've only specified a single container in your replica set, if the annotation would be used, linkerd would actually place another container inside of your pod without having to declare it explicitly. This is very interesting because your replica set, or in general your descriptions can be independent from the service mesh implementation. So the service mesh, for example, could add a container to your replica set, and one of the things you could do with the service mesh would be to install an end-to-end encryption. So let's say you're talking from one pod to another pod using a simple web service, and you'd like to have the communication between them. It's also called encryption in transit, and you would like to have it encrypted. So you could basically spin off a container that creates an encrypted connection to another container in another pod, while your pod will just talk to localhost, to the reverse proxy co-located in your pod. So this way you could add encryption to your application without having to declare it in your application itself. This is especially interesting if, for example, your application is a legacy application that you'll take from somewhere else, and you don't want to change the code of the application, but you still want to add the encryption. So there are many other applications of sidecar patterns, and there are many other applications of service meshes. But this is just to provide you an example where this is going. So there's a lot of utility in those little things that, well, that are a bit outside of this tutorial, but just to give you an idea on where to dig deeper. All right. Without linkerd, well, this line wouldn't be here. You can see that there's a label, and if we retrieve the pods and the namespace, you can see you get the simple Go web pod, but you can also see that there's a pod that has the name of our replica set, that contains the name of our replica set, and at the same time contains a random string. So now imagine you have many pods. You can then filter by using those labels and only select those resources that you are interested in. So especially for getting, in order to get an overview, this is very handy. All right, so let's look into the pod. So this is there's the regular pod definition, the labels, the image, status information, and what actually happened here on during creation of the pod. So for example, here it says, well, we already got the image, so we don't need to pull the information. We don't need to pull the container image because it was already located on the node. So the cluster has only a few nodes. If we schedule a pod on the same node and the node already has the container image, well, we don't have to pull it. All right, but it's basically a pod, and that's it. Now, let me check. Yeah. One thing that's also interesting to see, it may be covered in the tutorial later, is you'll have your pod here. This is the pod we've created in the last lecture. It is a regular pod. It is not related to a replica set, because then you would see that there is a random string attached to the name. So what happens if I delete the pod? The pod is gone because we've deleted it, obviously. Now we've declared a replica set. The replica set created the pod for us, and we will now delete the pod of the replica set, and simultaneously observe the list of pods. As you can see, the pod we've just deleted is in the state terminating, while there has been created a new pod with a different random string which is already running. So what happened here? So while this termination is still in process, the command blocks. So there's an abbreviation for replica set, so we can use RS instead of replica set. So you can see that the replica set triggered the creation of the first container, and because at some point there was a missing container, because the actual state was having no pods, a replica number of 0, but the desired number of replicas is 1. The controller created the missing container. So if you take the perspective and kubectl get replica sets and watch that, and we will then terminate we have to be quick. You can see here's the deviation. So desired is 1, current is 0, and it will correct that situation as quickly as a few seconds. I mean, in this case, this is easy because the container image has already been cached on the host, which means it doesn't have to pull the image, which may take minutes, depending on the image size. We generally strive for smaller images to reduce the number, to reduce traffic, and also startup times for cold startups where no image is present on the node. But in this case, the application image or the container image has already been pulled, and therefore starting a new container is a matter of seconds. So creating a new pod and starting a new container happens within seconds. So we've seen the last time that if a pod fails, the pod can already be recreated. But if you delete the pod, the pod's lifecycle ends. The pod is done. But with the replica set, you create a structure above the pod that will ensure that there is a pod according to the specification of the replica set. Whenever something in the cluster accidentally drops the pod will be automatically recreated. So you get another layer of self-healing by using a replica set. So, and just to give you an example, so here we have a replica set of 1. We could also increase the replica set to 4. So you can see that we have a desired count of 4, that there are already 4 pods created, but there are only 2 ready. And you can see that there are containers in the creation phase. And now, a few seconds later, we have 4 replicas in the replica set.